Today we begin Unit 10, which is all about three-dimensional figures. So last unit was all about two-dimensional figures and area. This will be about surface area and volume. Today's lesson, section 1, will be about cross sections and Euler's formula. So we'll start out with the definition of a polyhedron. That's just a solid that is bounded by polygons, aka faces, which we spent all last unit talking about. That enclose a single region of space. So here are some examples of shapes that are polyhedrons. You can see the polygon here, the triangle. Here's another triangle. In the back's another triangle. On the left side we have a triangle, and the bottom we have a rectangle as our base, enclosed by polygons. Therefore we have a polyhedron. Same thing is true about the box right below it. Over here, these are shapes that are not polyhedrons because they are not enclosed by polygons. They are three-dimensional shapes, which we'll talk about, but they are not specifically polyhedrons. Here's why. First of all you need to do is take a look at the base of this cone here. The base of the cone is a circle. A circle is not a polygon because it's not made up of sides, edges, vertices, anything like that. Same thing here with a sphere. There's no flat sides making up that shape. And then same thing here with the cylinder. We have the circular bases, which are not polygons. All right, so now we're going to get into cross sections. What these are is if you were to take like a three-dimensional shape and you were to cut it with a whatever, just cut it in different directions. These are the two-dimensional shapes that you would see at the face if you were to cut it. The formal definition is the two-dimensional figure formed by the intersection of a plane and a solid. And really what you're looking at here, so we have a cube, we're going to cut three different ways. What you're looking at here is where the solid and that plane meet. So I like to kind of color it in to maybe help me see that two-dimensional shape that's formed. This one's harder to see just because of the way I colored it. It wasn't perfect, but if you were to cut a cube horizontally, you'd end up forming a two-dimensional square at the face. If you were to cut this cube diagonally, this one's a little bit easier to see. What you end up forming then, when those two, when the plane and the 3D figure meet, you form a rectangle. And then over here, if you kind of cut it at this funny angle, what you end up getting is a trapezoid. So you can cut a cube different ways to form different cross sections, is what those are called, where those two things cross. So let's take a look here. It says describe the shape formed by the intersection of the plane and the solid. So if you'd like, just color it in to help you see it, or maybe you can see here the really dark shaded figure. So when this plane meets the sphere, what's formed is a circle. Up here we have what looks to be, if I can count my sides correctly, a pentagon. Almost just said polygon. We have a pentagon, a five-sided figure, and here if I cut this cylinder with this plane, what we end up forming is a rectangle. So that's really all a cross section is. So here's just a couple more for you. Describe the shape formed. So depending on how you cut it, you can end up with different results. Here, I'm just going to draw around it. We have a rectangle. And here, I see another pentagon. And here, if I cut this box-looking shape here, if I cut that at a funny angle, I end up forming a triangle. So it all depends on how you cut it, where you cut it, but you're really looking at where those two things meet, the plane and the 3D figure, and what shape is being formed if you were to cut it right there. Okay, so now we'll get into a little bit more of the vocabulary. So starting with a face, that's any flat surface of a solid object. So for example, this whole side here of this cube is a face. This thing right here, this left side of the box, is a face. Also, the front, the top, the bottom, the left, and the back side. Those are all faces. A vertex is where two or more line segments meet. That would be like the corners of this box, for example. So here's a vertex. Here would be another one. Here's just a few more. There's also other examples. And then an edge is where two faces meet. So that'd be these line segments that you see. These are all different edges. Okay, so taking a look here at Euler's formula, F plus V, so the number of faces plus the vertices, equals the edges plus 2. Okay, and here it tells you F is the faces, V is the vertices, E is the edges. So let's check Euler's theorem here with the following objects. So I need F, V, and E. So F is the number of faces. So we have a box here. So I see one on the top here, and of course one on the bottom. I see one on the left, and a face on the right. Also, this front side is a face, so that's 5, and the back side would be 6. We have 6 different faces that make up a box. The number of vertices, that's where all these line segments meet. So there's 1, 2, 3, 4, 5, 6, 7, 8. So the vertices is 8. Then I need the number of edges. So the edges here, it's going to look like I'm just drawing the whole outside of the box. But here's 1 edge, 2 edges, 3 edges, 4 edges, 5, 6, 7, 8, and then I have this long one across the top, 9, another long one across the top, 10, here's another one, 11, and one more, 12. So I have 12 edges. So Euler's formula says if I take F, which was 6, plus the vertices, so the faces plus the vertices, 6 plus 8, what I should get is the edges plus 2. It's always going to be plus 2. So 6 plus 8 is 14. 12 plus 2 is 14. So it checks out. But here's how we can really use this, and here's what we're trying to get to. So if we have a polyhedron that has 5 faces, 8 edges, how many vertices does it have? So we want to find the missing information rather than counting it all up, so we don't have to draw a diagram, because 3D shapes are very difficult to draw. So let's put this to the test. So the formula again was F plus V equals E plus 2. Faces plus vertices equals edges plus 2. And you just fill in your information. We have 5 faces. Don't know how many vertices, because that's what we're trying to find. The edges are 8 plus 2. So 5 plus V equals 10. Subtract 5. So that means this polyhedron must have 5 vertices. If you want to get creative, you can certainly try and draw it. But let's try another one here. If a polyhedron has 6 faces, I'll write the formula again. F plus V equals E plus 2. Again, that's Euler's theorem, Euler's formula. And then fill in the information that we're looking for. So the faces, there are 6. There are 8 vertices. How many edges will we have? Because that's what we're looking for. So E has to be my variable. 6 plus 8 is 14. Edges plus 2. Subtract 2. There are 12 edges. And we actually just did that right here. So there you go. That takes care of cross sections in Euler's formula.